This video is about the first and second derivatives and their graphs. Fill in the blank about the concepts. When f prime of a equal to 0, the point a f of a could be maximum, minimum, or stationary inflection. When f prime of x greater than 0, which means f of x is increasing. When f prime of x less than 0, then the function f of x is decreasing. When f double prime of a equal to 0, the point a f of a is inflection point if f double prime of x has a sign change. At x equals a. When f double prime of a equal to 0, the point a f of a is not inflection. If f double of x has no sign change at x equals a. In other words, a f of a is an inflection point only it has satisfied two requirements. One is f double prime of a equal to 0. Second, the f double prime of a has a sign change at x equals a. When f double prime of x greater than 0 means the function is concave up. When f double prime of x less than 0, the graph is concave down. This diagram for you to remember. See, for f prime of x less than 0, this two graph is decreasing. When f prime of x greater than 0, look at these two graph is increasing. When f prime of x equal to 0, it could be maximum, could be minimum, or stationary inflection. For f double prime of x less than 0, you could see this is all concave down. When f double prime of x greater than 0, this is a concave up. When f double prime of x equal to 0, it could be inflection only when this f double prime has a sign change. At that point. If second derivative has a sign change at that point, then it's a non-stationary inflection if the first derivative not equal to 0. It's a stationary inflection when the first derivative equal to 0. So remember, the second derivative of x equal to 0 doesn't mean this point is an inflection point. You have to check the sign change. Now we use this table to make a concept more clear. For f of x, minimum, maximum, then the first derivative definitely equal to 0. Stationary inflection point is equal to 0. When the graph is increasing, means the first derivative is positive. Decreasing function, it will be negative. For second derivative, if it's an inflection point, then it will be equal to 0. Concave up when the second derivative is positive. When the second derivative is negative, which means the graph is concave down. And also, if it's a minimum points, which means it's concave up, definitely it's a positive. When it's a maximum, it's concave down, so it will be negative. How to show f of a is a minimum point? There's two ways. First of all, you have to show the first derivative equal to 0. Then you have to show, using the first derivative, sign diagram at a, the sign change. Or you can using the second derivative of a is greater than 0. Normally we use this to show a point is a minimum point. So how to show f of a is a maximum point? We have to make sure the first derivative equal to 0. Then you can use the second derivative is less than 0. That's it. Or you can use the first derivative, do the sign diagram. There is a sign change. Or it could be like this. In other words, when you show a point is a maximum, we prefer this. So you get the first derivative equal to 0 and the second derivative less than 0. Then you show this point is a maximum point. So how to show f of a is a stationary inflection point? You just need to show the f prime of a equal to 0 and also the second derivative of a equal to 0. So how to show f of a is a non-stationary inflection point? You just need to show f prime of a not equal to 0 while f double prime of a equal to 0. Let's go to guided practice 1. The following diagram shows part of a curve of a function f. The point A, B, C, D, and E lie on the curve, where B is a minimum point and D is a maximum point. Determine f prime of x is positive, negative, or 0. You just need to check the graph is increasing. Then the first derivative is positive. Decreasing, that will be negative. For 0, you need to make sure it's a minimum, maximum, or stationary inflection point. Therefore, for A, this is going down, decreasing. Therefore, it's a negative. For B, this is a minimum, so here's a 0. For E, going down, still negative. For F, double prime of X is a positive, that means concave up. Negative means concave down. 0 means inflection point. We can use POI stand for that. Point of inflection. So for A, this is a concave up, positive. For C, it didn't say this is a point of inflection. So the curve is concave up, is a positive. For E, concave down is a negative. Guided practice 2. Use the graph y equals f of x below. Sketch the graphs of the first derivative and the second derivative. For the first derivative, we need to draw a sign diagram first. This is a maximum. That means it will be the 0. Minimum, here is a 0. We don't have a stationary inflection. So we can get going up is a positive. Going down is negative. This is a positive. You will connect these two first because below. Then going up. Here it's going up. But check the inflection point. You see, I have inflection point over here. This will be your maximum or minimum point on the f prime of x. Here, you do have a inflection point. Therefore, I will connect like this. This will be the maximum point, then it's going down. Now I will draw this graph on the original graph. So this part, it will be maximum or minimum. Inflection on the original function will be the maximum or minimum point on the first derivative graph. Therefore, I can draw like this. This part, I need like a maximum. This will be the f prime of x. Now, let's draw the second derivative function. So for the inflection point, that will be the x-intercept for the second derivative. So we draw the sign diagram. Going up, this is a positive. Going down, that is a concave down. So here is a negative. Concave up, here is a positive. So you just need to connect these two. Then going up. Going up. That's it. This will be the second derivative function. Now let's go to B. First of all, get the maximum minimum. This will be the x-intercept for the first derivative. This is a stationary inflection point, so still I will draw this. Then you will figure out the sign diagram for that. going up, positive, negative, negative. Here's a positive. Then get the inflection point. That will be your maximum or minimum of first derivative. Suppose over here. Here's 1. Okay, you can sketch the graph now. If it's a negative, so you will draw like this. You need to make sure the minimum point is on this inflection here. So let's draw that nicely like this. Going up, positive, then here's going up. That's it. So how you draw the second derivative function? You will find this inflection point, then draw the sun diagram. Going up, this is a positive. Here's a negative. This will be positive. So you need to just connect this going up. That's it. So this one is a second derivative function. If you are given the sun diagram, for example, I have this is a positive, negative, positive, the negative, here's negative. You have to know how to draw the graph. Say for positive, you just connect these two. Negative, go down. Positive, go up. Negative, go this way. And then here's going down. That's how you draw the graph if you know the sun diagram. Let's go to Guided Practice 3. Use the graph of first derivative below. Sketch a possible graph of y equals f of x. Show clearly the location of any stationary points and points of inflection. Remember, this is the first derivative graph. Therefore, the x-intercept will be the minimum points or maximum points or stationary inflection. Then we figure out the sign. This is a below x-axis negative, above positive. Here's a positive. This point, it's a stationary inflection point because no sign change at this point. And then the first derivative equal to 0. And this point here, the maximum point, will be the inflection point, non-stationary inflection point. Now we can sketch the graph like this. Going up, going down is easy, so we draw the graph like this here. Then you will get an inflection point over here. That this one still is a stationary inflection. Therefore, that will be the graph look like. We know this is a inflection point and this is a inflection point. Now let's go to B. For the B part, this one, this is the x-intercept, which means the maximum point or minimum point. Then draw the sign diagram. Above x-axis is positive, negative. Here's a positive. Then find the minimum or maximum point. It will be point of inflection. So we can sketch the graph like this. This is going up, and then you're going down. This will be the inflection point here. Then go this way. This is a minimum point.